Section 2.5, Equivalent Statements and De Morgan's Laws, Video 1. In this video, we will cover the following objective: determine if statements are logically equivalent. Let's start with a definition. Statements are logically equivalent if they have the same truth value for every possible case. If statements P and Q are logically equivalent, this can be denoted by P triple bar Q. Example 1. Use truth tables to determine if the statements, if the negation of Q, then P, and the negation of P, and the negation of Q if and only if Q or P are logically equivalent. So what we're going to do is we are going to make a truth table. And I'm going to show you how to use one table for both statements. We're going to make a column for P, and then we're going to make a column for Q. And we're also going to make a column for the negation of P and the negation of Q, because we're going to need those. Notice that those are both being negated within these statements. The P column will label true, true, false, false, and the Q column will label true, false, true, false. The negation of P would take on the opposite values of the P column, so that would be false, false, true, true. Negation of Q would take on the opposite values as the Q column, so that would be false, true, false, true. All right, so now what I'm going to do is I'm going to work with the first statement given, and I'm going to make a column for the parentheses in that statement. So that would be if the negation of Q, then P. If the negation of Q, then P. We're looking for a case where the antecedent is true and the consequent is false, because then the conditional statement would be false overall. That is the only case where that happens, so the rest of these will be true. Now I'm going to make a column for the entire first statement. So that would be if the negation of Q, then P, and the negation of P. So we are going to form a conjunction between the column we just created and the negation of P column. So we're putting an and between those. And statements are only true when both parts are true, which happens right here. So that will be true. If one or both parts are false, then the conjunction will be false. Okay, so this column right here represents the first statement. So we're going to keep that in mind because we're going to be using that when we compare at the end. All right, so now I'm going to make a column. I'm going to work on the second statement, and I'm going to make a column for the parentheses involved there, which would be Q or P. This is a disjunction. So we're putting an or between those columns. Or statements are only false when both parts are false. So in that last row there, the disjunction will be false. If one or both parts are true, then it comes out true. All right, and then lastly, I can make a column for the entire second statement. So it's the negation of Q if and only if Q or P. So we're forming a biconditional statement between the negation of Q and the column that we just created. Recall that biconditional statements are true when both parts have the same truth value. So here they're both true, so it will be true in that case. And that is the only row where both parts have the same truth value. So these other cases will be false. Okay, so then this column here represents the second statement. So basically what we need to do now in order to determine if these statements are equivalent is we need to compare the columns that contain the final truth values for those statements. And when I compare those columns, notice that the truth values are not the same in every possible case. So they're both false to start out with, but then in the second row, the first statement is false and the second statement is true. And so those truth values do not match in every possible case. And so therefore we can say that these statements are not logically equivalent. Example 2, use truth tables to determine if the statements provided are logically equivalent. In this case, since the truth tables would be so long, I'm going to do two different truth tables, one for the first statement and one for the second statement. So it's important that we start the two truth tables the same way. So we have a P, Q, and an R. And so I'm going to label the P column like this. We do this the same way every time. And this has been covered in previous videos about why we're setting it up like this. But it's going to be important that the second truth table that we are going to make to represent the second statement, it's important that we start that the same way. Otherwise, we would not be able to compare them. So I'm going to do this right away just so that I can ensure that I will be able to compare them. Okay, so if I look at the first statement, notice that R is being negated, so I'm going to need a column for that. So that would be false, true, alternating. Then I'm going to make a column for the first set of parentheses and then the second set of parentheses. So we have P or the negation of R. And then we have P and Q. Okay, so we're going to form a disjunction between P and the negation of R. Recall that OR statements or disjunctions are only false when both parts are false. So that's happening right there, and that's also happening right there. So those will be false overall. The rest of these will be true. Okay, P and Q, so we're forming a conjunction between the P and Q. Recall that AND statements or conjunctions are only true when both parts are true. That happens in the first two cases there. Otherwise, it's going to be false. All right, lastly, we are forming a conditional statement between these. So we have if P or the negation of R, then P and Q. So now I'm making my final column will represent the entire statement. So we have if, then. If then statements or conditional statements are only false when the antecedent is true and the consequent is false. That's happening in two places there. Oh, and two more places. So those are all the cases where the antecedent is true and the consequent is false. In all these other cases, this will be true. Okay, so now we can make a truth table to represent the second statement. And I'm going to need to make columns for the parentheses. So this would be the negation of P or, oh, actually, I'm going to need to make columns for negations. So we need a column for the negation of P, and we're also going to need a column for the negation of Q. So let's start there, because notice that those statements are being negated. So I'm going to need those. So the negation of P would be false, 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 true, 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 true. The negation of Q would be two falses and two trues alternating. All right, now I'm going to make columns for the parentheses. So the first one would be the negation of P or the negation of Q. The second set of parentheses is the negation of P and R. So we're putting or between the negation of P and the negation of Q. Or statements are false only when both parts are false. Otherwise, this will be true. Okay, and then we're putting an and between the negation of P and R. So we're forming a conjunction there. And statements are only true when both parts are true. So that happens in those cases there. Otherwise, it's going to be false. All right, then lastly, we are going to make a column for the entire second statement, which is if the negation of P or the negation of Q, then the negation of P and R. So we're forming an if-then statement again, if-then. Which will be false if the antecedent is true and the consequent is false, which happens in those cases there. Otherwise, it's going to be true. And then again, in order to determine if these statements are logically equivalent, we are going to compare the columns in the truth tables that represent those statements overall. And so that would be the last columns of these truth tables. And if we compare, we'll notice that these truth values are exactly the same in every possible case. So you'd have to compare all 8 of those truth values and make sure that they match. And they do. And so I know that these statements are logically equivalent. So in this video, I showed 2 different methods. One method is to use one truth table and just make columns for the 2 statements that are being compared. And then we are comparing the truth values in those columns. The other method is to make 2 separate truth tables, one for each statement that we're comparing. And if we were comparing more than 2 statements, then we could make however many truth tables we need. This concludes example 2.